Now we're going to switch focus and do the fun stuff, which is actually build a solution live. So with all live demos, wish me luck. Yeah, I'm going to sit down, model a business network, get it deployed to a fabric that's running on my laptop, expose it via REST API, and then even generate a simple little web application that interacts with the network. Okay, let me get out of PowerPoint. And the first thing that I would like to show you is the Fabric Composer, which is the old name, a homepage. The new name is Hyperledger Composer because we've just moved into the Hyperledger organization. But if you go to the Hyperledger Composer homepage, one of the first things that we encourage people to do is to check the tutorials and to run the quick start, which essentially just verifies that you have all of the prerequisites installed and kind of brings down, installs Composer onto your local laptop. So I obviously already have the prerequisites installed, and I've already installed the Composer CLI, the command line interface that you use for managing Composer. And I've also cloned the sample applications repository, which is this guy. So what I'm going to do now is I'm going to just go into that directory, and I'm going to run npm install. And this is going to take a few moments. The first thing it does is it verifies that I have the CLI installed, and you can see that it's just echoing which version of Composer I'm using. So I'm using 0.5.12. And then what it's going to do is it's going to start a local Hyperledger fabric, and it's going to deploy this very simple sample digital property network to that fabric, which is underway at the moment. So you can see deploying business network definition. This may take a minute. Command succeeded. That's a good sign. And then we list the business network definition, and we get some metadata back out of it. So we're not too worried at this point about the digital property network, because we're going to create a brand new network from scratch. But what I do want to show you is, if I run docker ps -a, we now have 3 Docker containers that are running on my machine. This is Hyperledger 0.6, so we've got the member services container that manages access to the fabric. We have a peer, a single peer, which is kind of our entry point into the fabric. And then we have this Docker image, which is what Hyperledger calls a chain code container, which is where our business network is actually executing. The logic that we write as application developers is going to execute inside this Docker container. And you can see that each of these containers have just started. So that npm install that we just ran basically brought up a very simple development network that we can use on our local laptop. If you want a slightly more visual way, on the Mac you can run Kitematic. And we can see the 3 containers that are running, and if I click on one of the containers, you will even see the logs for that container. So that can be useful for for just understanding what's going on. Okay, so we have a fabric, it's up and running. We've actually deployed one business network already, which is this digital property network. But as I said, we're going to create a new one from scratch, just so that you can understand what's going on under the covers. Right, so what So there's a few different places that you can start. But what I typically recommend is that people start in the Composer Playground. And the Composer Playground is basically a very low friction, web-based development environment to explore the Hyperledger Composer concepts. So if you go to composer-playground.mybluemix.net, you should see a screen that looks like this. Let me make that a little bigger so you guys can see it. And essentially we're browsing a business network at this point. So down the left we see the model for the network, we see a script file for the network, we see the access control for the network, and we see some metadata about the network. So this is sort of a viewer browser for a business network definition. And what we're going to do is we're going to essentially sort of start hacking on this hello world sample and make it do something a little bit more interesting. So the first thing that we need to do is we need to define our business model. So define the structure of the assets, participants, and transactions that make up this business network. So if I click on the model file, you'll see right now we've got an asset called sample asset, a participant called sample participant, and a transaction called sample transaction, so not very interesting. And they're all placed in the org acme sample namespace. And so this is the definition of a data model, and it uses this domain-specific language to describe the structure of the data model. And if I start typing in here, you'll see that I get real-time keystroke by keystroke error detection for syntax errors and other kinds of errors as I introduce them. But what we're going to do today is we're going to imagine, in the UK where I'm based, fintech is really hot right now. Various people are working on unbanking, right? New forms of digital banks. So let's pretend that we're going to create a new digital bank, and we're going to back that bank with a blockchain. And maybe discuss why we would do that later. But obviously, if we're creating a bank, one of the key assets that a bank has to manage is the bank account. So we're going to change this asset definition from sample asset to say we have an asset that's an account, and it's going to be identified by an account ID, and we need to have an account ID property. And an account has an owner, so that's good, but we don't want to call the owner a sample participant. We're going to call them a customer. And for our simple purposes, we can say that an account has a balance, which is a double. And we can see we're getting some errors here. It's saying that there's an undeclared type customer. Well, we haven't actually declared what a customer is. So we're going to change this participant to be a customer. We're going to say he's identified by a customer ID. Customer ID. And the customer has a first name and a last name property. Now we're going to have some sort of a transaction, and just for simplicity's sake, we're just going to deal with account transfers, at our initial cut at this, this new blockchain-based digital bank. So I'm going to model a transaction called account transfer. And an account transfer is related to two accounts. The account that we're moving money from and the account that we're moving money to. And we also want to specify how much money we want to move. So now, we get this nice reassuring, everything looks good message at the bottom, because our model is now syntactically and semantically valid. We have this account asset, which is related to a customer. An account has a balance. Customer has a first name and a last name, and an account transfer moves some amount of money from one account to another account. So given that everything looks good, we can now update the business network definition, right from within the browser. So I'm going to press this update button. And if I go to the test tab now, you'll see that under participants, assets, and transactions, we now see customer account listed here because they've been modeled in the network. So we're not going to create any instances yet. We'll do that in a moment because we haven't actually written the logic for this network. We haven't written the code that's physically going to move balance from one account to another. So let's go and think about how to do that. I'm going to flip back to the Define tab and look at this script file. And this script file has got a plain old JavaScript function inside it. And this is the function that's going to get triggered when somebody submits an account transfer transaction. And the way it does that is using some JS doc annotations. So I'm going to add an annotation at transaction. And I'm going to add an annotation at param. And I'm going to say this function is basically subscribed to instances of account transfer. And I'm going to change this function name to be account transfer. And you can see we're starting to get error detection on the JavaScript itself, because this annotation requires the name. So now what I've essentially told the runtime, so I'm just going to tidy this up. So transfer funds from one account to another. So using these two annotations, we've told the runtime that when anyone submits an instance of our account transfer, we want to run this JavaScript function over the account transfer transaction. And then within the body of that JavaScript function, I can start to create assets, update assets, remove assets, create participants, update participants, remove participants. And I do that by using these runtime APIs like get asset registry, update asset within a registry, etc., etc. So I'm going to cheat a little bit now because the chances of me, typing 50 lines of JavaScript into a web page during a live demo are slim. So I'm going to take one I prepared earlier, and then I'll walk you through it. So we have that account transfer function. It's subscribed to the account transfer transaction type. And the first thing that we do in our function is we want to make sure that the from account of the account transfer, the balance of that count is, if the balance of the account we're moving money from is less than the amount that we're trying to move, then we can't move the money. So in this case, we simply throw an error which is insufficient funds. If that condition is not true, then we reduce the balance of the from account by the amount that we're transferring, and we increment the balance of the to account by the amount that we're transferring. So we've modified two assets at that point. We've modified the from account asset and the to account asset. So what we now need to do is we need to store those assets back into their asset registries so that those changes are persisted. So we're going to get the account asset registry, and then we're going to update the from account, and then similarly we're going to update the to account. And it's kind of important to bear in mind that all of those changes are atomic, right? They will either all happen or they won't happen. We'll never be in a situation where, you know, we've updated the from balance, but we haven't updated the to balance. This, you know, this underlying Hyperledger Fabric transaction is either going to be completely committed to the ledger or it won't be committed at all. And all of the peers that, you know, are running this business network have got to agree on what the side effects are of processing this transaction. And if any of the peers disagree, you know, on what the, say, the to balance should be, then there'll be a consensus failure, and the transaction also won't be committed. Right, so we've written now, you know, super simple little toy digital bank here that's backed by a blockchain. So I'm going to update the business network definition again so that those scripts are deployed. And now, you know, now we can start to play with it using the test tab. So before we can, you know, test a scenario interactively, we've got to create, obviously, you know, a couple of customers and a couple of accounts, so we can try moving some money around. So I'm going to click on the customer participant and create a new participant. The customer ID is going to be Dan, because that's the identifier. First name is Dan Selman. I have to make my, just have to reduce my resolution a bit, sorry. So the customer ID is Dan, the first name is Dan, the last name is Selman. I'm going to create a new customer. So we now have an instance of the customer type. They're a participant, and they live in this customer registry. So this is where we would see all the instances of customers. Right now we only have one whose ID is Dan. And I'm going to create a second one whose ID is Simon. First name Simon, last name Stone. So we've now got two customers that live in this participant registry. And now let's create accounts for those participants. So I'm going to click on the account registry, create a new account. The account ID can be Dan account. The owner of this account is going to be Dan. And the balance of the account, let's say, is 1,000. Slightly optimistic, but hey. Now let's create an account for Simon. So his account ID can be Simon account. The owner is Simon, and the balance for Simon is 10. So we've got two customers, two accounts, and the accounts are linked to the customers using these, you know, these relationships. So now let's submit a transaction. And you can see we've got one type of transaction that we've modeled, which is the account transfer. And what we're going to do is we're going to move some money from the Dan account to the Simon account. And I'm going to move 75 units. And when I, you know, press submit transaction, the transaction gets added to the transaction registry. You know, so we have this kind of durable copy of the transaction that's also stored on the blockchain. And then if I click on the account itself, we can now see that Dan's balance is 925, so 1,000 minus 75. And Simon's account balance is now 85, so 75 plus 10. So our business logic worked, which is, that's pretty cool, right? We've modeled this notion of a single participant type, which is a customer, and a single asset type, which is an account, and a single transaction type, which is an account transfer. So I'm feeling pretty good at this point. I've captured my business requirements, if you will, and I've done all of that, quite interactively within this web-based tool, zero install, and you can even do this if you're working in consulting. You can even do this live in front of your customers to create that sort of really, fluid ideation kind of experience, or design thinking experience. But what I really need to do now is I want to test this, running on that fabric that I've started, that's running on my local laptop. So I'm going to download the business network archive that we've created here. So I'm going to export it, and then I'm going to show you how to use some of the command line tools to deploy it to what might be a production fabric, if you will, and then we're going to create an application that interfaces with it. But before I do that, and before I forget, I'm going to change the metadata of this network, because I don't really want the network to be called basic sample. That would be giving the game away. So I'm going to rename the network to be Dan Bank -network, and I'll change the version to be 001. Now I'm going to export the business network archive, and you should see that was pushed through my browser to my downloads folder. And what I'm going to do is I'm going to deploy that business network to the fabric that I've got running on my laptop. So I'm going to do that using the Composer command line utility, which I have installed. So if I type Composer, you can see the top level commands that are supported. And the key one for me right now is Composer network deploy. I want to deploy a new network to that fabric that I'm running. Again, I'm going to refer to my cheat sheet just so I don't mess this up. So I'm going to run the command Composer network deploy, supply the path to the business network archive that I just downloaded, which is called danbank-network.bna. And then I have to supply the enrollment ID and enrollment secret for the user that I'm going to use to do this deploy. So this enrollment ID and enrollment secret are, it's credentials that have already been created on the fabric. So the person that installed the fabric or configured the fabric would have created this identity for me. So I've launched the command, and it's saying deploying business network definition. This may take a minute, and the reason it may take a minute is it's going to start a brand new Docker container that's going to run the logic that we just wrote, and that's kind of key. It means that each business network definition is running with that degree of isolation. They're each running inside their own Docker container, which has some nice properties in terms of isolation, as I said, but also management of the networks. So the command succeeded, and if I run docker ps -a, sure enough, you now see another Docker container has been created. And it's been up for 22 seconds. So this is the Docker container that we'll be using to execute the Dan Bank business network. And as you can see, on a given fabric, you can have multiple business network definitions deployed, and they're all sort of isolated from each other. They're all running in their own Docker containers, and they're all getting their own views into their own asset registries. So you get kind of quite a nice multi-tenant story as well. Similarly, if I look in Kitematic, you'll see that we now have 4 Docker containers, and we can see the logs for the network that I just started. Okay, so our network is up. It's deployed. So now what I want to do is I kind of want to transition into the application building phase. I'd like to build a mobile application or something for this new DAN bank, because we're not, I can't afford to buy a lot of real estate and have branches, so it's going to be a completely internet-based bank. So what I want to do is I don't really want my mobile developers or my Angular developers or my React developers to have to be blockchain experts. I want to put a REST API in front of my blockchain so that my application developers are just working with that REST API. They don't even know that there's a blockchain behind it. And Composer has a very nice tool to help you do that. So I'm going to run the Composer REST server. And the first thing it asks me is for the name of a connection profile. And in Composer, we use this notion of connection profiles to know how to connect to a fabric. Let me just show you one to make it a bit more concrete. So connection profiles by default live in the home directory in this .composer connection profiles folder. And there are subfolders under there, and one of the subfolders in this case is called default profile, and it contains a single JSON document called connection.json that tells us how to connect to a fabric, using this logical name default profile. So it's got the URLs, the IP addresses, to connect to the peer, to connect to the event hub. And in this case, we can see that using this default profile, we've deployed two networks to it. We have Digital Property Network deployed using this chain code ID, and the DAN bank network deployed using this chain code ID. So that's, this notion of a connection profile is a nice way to abstract the applications from, all these configuration parameters. You just give Composer the name of a connection profile, and then we resolve all this stuff, through these configuration files. So I'm going to connect to the fabric using this default profile. And I want to generate a REST API for the DAN bank network. And I have to give some credentials. So web app admin. I better get that right, don't I? Web. Let me check my cheat sheet. Yeah, web. Web app admin. And the secret is that. And then, because, as you saw, Composer models have namespaces, you can decide whether you want to expose those namespaces through your REST API or whether you want to suppress the namespaces. And in this case, I'm going to use the namespaces. So I will always use namespaces, which just essentially become a prefix to the URLs that are generated for the REST APIs. Do I want the REST API to be secured? In this case, I'm going to say no, just because it speeds up the configuration and the demo. But the Composer REST server does support pluggable Passport.js authentication. So if you wanted to secure access to your REST API using any of the providers supported by Passport.js, that should work. So what the Composer REST server is now doing is it's physically connecting to that fabric, connecting to the business network definition called DAN bank-network. It's introspecting the models for that network, and then it's generating dynamically a REST API based on those models, which I can then browse by going to this URL here. So I'm going to open that URL. And what I get is the loopback explorer. So Loopback is the open source framework that Composer uses to generate and manage its REST APIs. And you can see that the Composer REST server has discovered that there's an asset called account, a transaction called account transfer, and a participant called customer. And if I click on an account, you can see I have the usual kind of REST verbs to create, read, update, and delete instances of those types. So if I click on Get for an account, and I click the Try It Out button, you can see that the response body is empty because I don't have any accounts yet, on this fabric that I'm connected to. But the response code is 200, which is good. There was no error. So what we're going to do is we're going to try and create an account using Loopback. So to create an account, I'm going to use the post verb, and I'm going to say that the account ID, actually no, before I create an account, let me create a customer. Because the account is related to a customer, so better to create the customer first. So let me run a post on the customer URL. The customer ID is going to be Dan, first name Dan, last name Salman. Try it out. We got a 200 back, and the response body is the JSON for the account we just created. Let me create a second one. Customer ID is Simon. First name Simon, last name Stone. And now if I do a get on customers, you see the response body is an array of 2 customer instances. And those are physically stored on the blockchain. So I can give this Swagger document, this Open API document, to my application developers, and they can code against it and interact with the blockchain, but via this standards-based API. They don't need to know anything about blockchain or the Composer SDK in order to interact with the solution. So we've created 2 customers. Now let's create an account. So the account ID is Dan account. The owner is Dan. The balance is 100. Good. And now let's create Simon's account. His balance is 500. We get all the accounts. Yeah, we now have 2 accounts. And then the last thing we can test is an account transfer. So we should see that we've generated a route for the account transfer. And because account transfer is a transaction type, it only has a post. So the only thing that we can do through the REST API right now is to post new transactions into the runtime. So we're going to move money from the Dan account to the Simon account, and we're going to move 50. We get a 200 back, and if we now check, we do a get on the accounts again, we can see that Dan's account balance is now 50 and Simon's account balance is 550. So we've run exactly the same logic. We've just done it through the REST API. So the last thing I want to show you is, okay, we've generated a REST API, that's great. How do we create an application? Well, Composer also has a Yeoman-based code generation template facility to kind of bootstrap your web application development. So if I type Yo, which is the Yeoman code generator, you can see we've got a Yeoman generator for Composer. So I'm going to run this Composer code generation plugin, and I can then select some different options. Do I want to generate a CLI application, an Angular application, or a skeleton business network? So I'm going to create an Angular application. Do I want to connect to a running business network and introspect it? I'm going to say yes. What's the name of the application I want to create? I'm going to call it the Dan Bank app. The description is, Dan Bank. The author is Dan. My email. The network identifier is danbank-network. And I'm going to use the default profile to connect, the default enrollment ID and enrollment secret. And it's going to connect to that running network, introspect it, and generate Angular components for the asset types that it discovers. And you can see those here. It's discovered that there's an asset type account, and it's generated the Angular scaffolding and components, services, etc. for that asset type. So it's now installing all of the dependencies for that Angular application, which is probably going to take a few minutes. So we're going to leave that running in the background.